Hello everyone. In this video we are going to continue our discussion about plants and more specifically we are going to focus on the nutrients in the soil, how the plant will get these nutrients, what are the types of nutrients or minerals in the soils, and how they affect the growth of the plant. So let's start. So first we are going to discuss the soil texture. So soil is classified into layers, so it is stratified layers. Each one of these layers is called horizon. So as shown here in this figure, we have three horizons, A, B, and C. The top one of them, so horizon A, is called topsoil, and this is an important one because this is rich in minerals, living organisms, and the humus. So the humus is the decaying organic material. So the topsoil is rich in all of these components, and that's why it is one of the most important horizons. The type and the distribution of these horizons reflect the bedrock and so the bedrock underneath and the accumulation of materials during time. So starting with the topsoil, we can see that topsoil actually varies from one soil to another, so it can be a few millimeters in depth in a porous soil, or it can be meters in depth in a nice and healthy soil. So moving on to the characteristics of the topsoil, we will find one of the best types of topsoil is the loams. So it is the most fertile topsoil. It contains equal amounts of sand, slate, and clay. So sand, slate, and clay are three types, and they differ in their particle size. So sand is the biggest in terms of particle size, then comes the slate, which is kind of intermediate, then the clay is the smallest in terms of particle size. So sand is the biggest. That means it cannot get too compact, so that means there are spaces in between the sand molecules. So if we have a soil that is rich in sand, that's something good because these gaps will allow the infiltration of water. But if the majority of the soil is composed of sand, that means we may lose the water because of excessive infiltration. Moving on to the clay. Clay is the smallest of them in terms of particle size, so water will not be able to infiltrate so much, so water loss will not be a problem, so this is an advantage. But however, because of that being too compact, we may end up with the problem of waterlogging. So this is one of the pitfalls of having a soil that is mainly composed of a clay. The other disadvantage is that because of the compact structure, the penetration of the root into a soil that is rich in clay will be hindered, and because of that we will have a shallow root which may affect the ability of this root to absorb water and nutrients. So because of that, the best or the most fertile topsoils is the one having a combination of the three different particle sizes, so the sand, slate, and clay. And as we said, the loams is the one that has equal amount of each of the three particles. So in this figure, it shows that when we have a soil that has high clay content, the root system is going to be shallow. As we said, because of the compact structure, the root cannot penetrate, and this can affect the growth of the plant. We will have a poor soil condition. On the other side, a good soil should have good structure and spaces for air and water movement. So, but these spaces shouldn't be too big because water will infiltrate too much and we will lose it. So a mixture between the three different types which is the loam, would be the most fertile one. Okay, so in the coming slides we are going to focus on the organic components and the inorganic components that are present in the topsoil. So in terms of the organic components, we have the humus. So as we described it before, it is the organic matter that is produced by the decomposition of dead organisms, feces, and detritus. So this organic material is very rich in the elements that was in the producers of this organic material. So when they are decomposed and these elements are returned back to the soil, that makes this soil a very good reservoir of mineral nutrients. It increases the capacity of the soil to exchange cations, as we will see in the next slide. Also, it makes a crumbly soil that retains water, but still it is porous enough not to cause the problem of water logging. Moving on to the inorganic components. So in this slide you will see that we will classify the inorganic components into cations and anions. And as you know, the cations are the positively charged ions, the anions are the negatively charged ions, and the reason for this classification is that the steps that the plant will get the cations from the soil is different than the uptake of anions. So the cations, the positively charged ions, for example, potassium, calcium, and magnesium, because of the charge, they will adhere to the surface of the soil particles. The surface of the soil particles are being negatively charged. So because of attraction between opposite charges, the cations will adhere on the surface of the soil particles. This is important because this will stop the cations from being leached out. So remember the infiltration of water and the percolating groundwater. So the cations are not removed because of the attraction to the negatively charged soil particles. So as shown here in this figure, the soil particle is negatively charged like that, and that's what attracts the cations which we have mentioned, and the example potassium, calcium, and magnesium. Okay, so how the cations are released from the soil particle to enter into the root hair. Remember, the plant needs some of these inorganic components, and specifically we are talking here about the cations. So let's imagine that the root of the plant needs to absorb this cation, this calcium cation. So what will happen is what we call cation exchange. So two of the protons will be exchanged with the calcium ion. So two protons will be given to the soil particle in exchange with the calcium ion, and that will maintain the charge. It will not change it. And why we said two? Because the calcium is dication, or 2+ in terms of the charge. Okay, so this displacement or this cation exchange is the way that the calcium will enter the root of the hair. But what are the sources of these protons? What are the sources of that? So the sources is the release of carbon dioxide from the root of hair by respiration. So carbon dioxide is released. Carbon dioxide in presence of the water in the soil will form this molecule, this carbonic acid. This carbonic acid will ionize into the bicarbonate and the proton. So imagine this process happening twice. We generated now two protons. These two protons will be exchanged with one calcium cation. So the calcium will be released in exchange with two protons. Then the displaced cations, calcium in this case, will enter the soil solution and can be taken up by the plant roots. So here is the calcium, and it will continue its movement till reaching the different organs of the plant. How is that? That it was covered in a previous video. So crossing the epidermis, then the cortex, then the endodermis, then crossing the Casparian strip, and so on. When it comes to the negatively charged ions, this is more difficult. So the uptake of these negative charged ions is more complicated because they can be lost from the soil by leaching. So remember, the positively charged ions, they are attached to the soil surface because of the attraction between opposite charges. So the negative charged ions, there is no mechanism to maintain them in place. There is no equivalent mechanism to the uptake of positively charged ions. That's why the uptake of the negative charged ions can be problematic, because they can be leached or washed out with infiltration of the water. Moving on to the topic of adjusting the soil pH, and if you do planting, or if you know a farmer, you will know that adjusting the soil pH is a very important factor in that affects the growth of the plant. Why is that? Because the soil pH affects the cation exchange and the chemical form of the minerals. What does this mean? So let's start with the cation exchange. Cations are more available in a slightly acidic soil. So imagine a slightly acidic soil will have proton ions, and if you remember, proton ions will be exchanged with the cations, meaning that in a slightly acidic soil we will have more cations that have been displaced and they are readily available in the soil. So they'll be displaced from the soil particles and they will be available in the soil. So that's good. That's something good, meaning that the cations will be available for the uptake by the plant root. However, if the pH of the soil is too acidic, that means that we may have now toxic minerals available. So because of that, the slightly acidic soil is preferred. That means availability of cations in the soil to be absorbed, while a very acidic soil should be avoided, because this may lead to the toxicity of the plants. Why? Because the minerals there will be actually changed in their status. So how is that? An example of that is the aluminium. So at strongly acidic pHs, that is below 4.5, what will happen? This aluminium will become as aluminium 3+. This will be now soluble in the water, will be absorbed by the roots, but it will be toxic to the root. So the pH, here we are talking about pH below 4.5. So the pH can really cause toxicity to the plants. That's why, as we said, slightly acidic soil is preferred, but not too much acidic. Here is an example how the decrease of the soil pH can lead to the death of the plant. And here again, the example of the aluminium and the toxicity caused by a pH lower than 4.5, and how it affects plants, causing aluminium toxicity. So as you can see here, if the pH is below 4.5, we may have this growth of the roots of the plant, while if the pH is above 4.5, we will have healthy plants like that. It is shown here again in this image, the aluminium toxicity and the healthy plants, and as we said, it is all about having a soil that is too acidic.